There are several potential causes for elevated voltage readings at garage receptacles, which are damaging garage door opener circuitry. One possibility is a ground fault in the garage wiring or components. Inspect the wiring and components for any loose connections, damaged wiring, or faulty appliances that could be creating a ground fault. Another potential issue is miswiring. The garage receptacles may be miswired, with the neutral and ground wires reversed. This can cause short circuits and damage to the garage door openers. Verify the wiring connections to ensure they are correct according to the 2008 National Electrical Code. Overloading the circuit could also be contributing to the problem. If too many appliances or devices are connected to the 20 amp circuit, it can cause voltage drops and excessive heat build-up in the receptacles. Check the total wattage of all devices plugged into the circuit and ensure it does not exceed the circuit's capacity. A missing or damaged neutral ground bond can disrupt the electrical balance, leading to elevated voltage readings. Inspect the neutral ground bond at the electrical panel and ensure it is properly connected. A bad ground rod can also cause problems. The ground rod provides a path for electrical current to flow into the earth. If the ground rod is damaged or corroded, it can result in inadequate grounding and elevated voltage readings. Check the condition of the ground rod and replace it if necessary. In some cases, the garage may have an isolated ground system separate from the main electrical panel. This can lead to voltage differences between the garage and other parts of the house. Consulting with a qualified electrician is recommended to determine if this is the case and if it needs to be addressed. Here are some recommendations for troubleshooting the problem. Firstly, turn off the circuit breaker supplying the circuit and unplug all devices from the garage receptacles. Secondly, use a voltage meter to check the voltage readings at multiple points along the circuit. These points include the electrical panel, the garage receptacles, and the garage door openers. Compare your readings to normal expected values. For example, hot neutral should be approximately 120 volts, hot ground should be approximately 120 volts, and neutral ground should be close to 0 volts. Thirdly, inspect the wiring connections at the panel, the garage receptacles, and the garage door openers to ensure they are correct and tight. Check for loose or corroded connections, which can cause voltage drops and other problems. Fourthly, use an insulation tester, also known as a megometer, to check for any potential ground faults in the wiring. This device applies a high voltage to the wiring and measures the resistance to ground. A low resistance reading indicates a ground fault. If you are unable to resolve the issue or if you suspect more serious electrical problems, it is crucial to contact a licensed electrician. Electricity can be dangerous, and it is always best to err on the side of caution. The electrician will be able to properly diagnose the problem and make the necessary repairs. Focusing on some potential root causes in more depth, firstly, let's consider a ground fault. A ground fault occurs when there is an unintended connection between a hot wire and a ground wire or a grounded metal object. This can happen due to damaged insulation, loose connections, or faulty appliances. When a ground fault occurs, current flows through the ground wire instead of the intended circuit path, which can cause the elevated voltage readings observed. To check for ground faults, start by visually inspecting the wiring for any signs of damage. Look for frayed insulation, exposed wires, or burn marks. Pay close attention to areas where the wiring may be rubbing against metal objects or exposed to moisture. Use an insulation tester to check the insulation resistance of the wiring. Disconnect the circuit from the power source and connect the insulation tester between the hot wire and the ground wire. A reading of less than 1 megohm indicates a potential ground fault. If you find a ground fault, repair the damaged wiring or replace the faulty component. Secondly, miswiring can also cause elevated voltage readings. The most common type of miswiring is reversing the neutral and ground wires at the receptacle. This can create a situation where the neutral wire is energized, which can damage sensitive electronic equipment. To check for miswiring, use the receptacle tester. This device plugs into the receptacle and indicates whether the wiring is correct. If the receptacle tester indicates a wiring problem, carefully inspect the wiring connections to ensure they are correct. The hot wire should be connected to the brass terminal, the neutral wire should be connected to the silver terminal and the ground wire should be connected to the green terminal. Thirdly, overloading can also contribute to the problem. When a circuit is overloaded, the voltage drops, which can cause excessive heat buildup in the receptacles and damage to connected devices. To check for overloading, determine the total wattage of all devices connected to the circuit. Add up the wattage of each device and compare the total to the circuit's capacity. A 20 amp circuit at 120 volts can handle a maximum of 2400 watts. If the total wattage exceeds the circuit's capacity, reduce the number of devices connected to the circuit or move some devices to another circuit. Fourthly, a missing or damaged neutral ground bond can also cause elevated voltage readings. The neutral ground bond is a connection between the neutral wire and the ground wire at the main electrical panel. This bond provides a path for fault current to flow back to the source, which helps to trip the circuit breaker in the event of a ground fault. If the neutral ground bond is missing or damaged, it can disrupt the electrical balance and cause voltage fluctuations. To check the neutral ground bond, use a voltmeter to measure the voltage between the neutral wire and the ground wire at the main electrical panel. The voltage should be close to 0 volts. If the voltage is significantly higher than 0 volts, there may be a problem with the neutral ground bond. Inspect the connection between the neutral wire and the ground wire at the panel to ensure it is tight and secure. If you find any corrosion or damage, clean the connection or replace the bonding wire. Fifthly, a bad ground rod can also contribute to the problem. The ground rod provides a path for electrical current to flow into the earth. This helps to stabilize the voltage and protect against electrical shock. If the ground rod is damaged or corroded, it can result in inadequate grounding and elevated voltage readings. To check the ground rod, visually inspect it for any signs of damage or corrosion. The ground rod should be driven at least 8 feet into the ground. Use a ground resistance tester to measure the resistance of the ground rod. The resistance should be less than 25 ohms. If the resistance is higher than 25 ohms, the ground rod may need to be replaced or additional ground rods may need to be installed. Finally, an isolated ground system can also cause voltage differences. An isolated ground system is a separate grounding system that is isolated from the main electrical panel. This type of system is sometimes used in sensitive electronic equipment to reduce electrical noise. However, it can also create voltage differences between the garage and other parts of the house. To determine if the garage has an isolated ground system, consult with a qualified electrician. The electrician can test the grounding system and determine if it needs to be addressed. In summary, troubleshooting high voltage readings at garage receptacles requires a systematic approach. Start by identifying potential causes, such as ground faults, miswiring, overloading, a missing or damaged neutral ground bond, a bad ground rod, or an isolated ground system. Then, use appropriate testing methods to verify the cause of the problem. Finally, repair the problem or contact a qualified electrician for assistance. Remember to always turn off the power before working on any electrical wiring. In addition to the above-mentioned points, consider these additional factors. Check for shared neutrals. In older homes, it was sometimes common to share a neutral wire between 2 circuits. If the shared neutral is overloaded or has a poor connection, it can cause voltage fluctuations on both circuits. Check for aluminum wiring. Homes built in the 1960s and 1970s may have aluminum wiring. Aluminum wiring is more prone to corrosion and loosening than copper wiring, which can cause electrical problems. If the home has aluminum wiring, it is important to have it inspected by a qualified electrician. Ensure proper grounding of metal boxes. Metal electrical boxes should be properly grounded to prevent electrical shock. Check the grounding connections to the metal boxes to ensure they are tight and secure. Inspect the service entrance. The service entrance is where the power lines from the utility company enter the home. Inspect the service entrance for any signs of damage or corrosion. Contact the utility company if you suspect a problem with the service entrance. Be aware of back circuits. A back circuit is a circuit that is being powered from an external source, such as a generator. Back circuits can be dangerous and can cause damage to electrical equipment. Ensure that any back circuits are properly isolated and protected. Understand the importance of GFCI protection. GFCI receptacles are designed to protect against electrical shock. They are required in wet locations such as bathrooms and kitchens. The garage receptacles should be GFCI protected to prevent electrical shock. It is critical to use a calibrated digital multimeter. The accuracy of voltage readings is directly dependent on the quality of the meter being used. A cheap or poorly calibrated meter may provide inaccurate readings, leading to misdiagnosis of the problem. Ensure the meter is set to the correct voltage range. The meter should be set to alternating current voltage or volts alternating current and the appropriate voltage range. In the United States, most residential circuits operate at 120 volts, so a range of 200 volts alternating current would be suitable. Check the meter's test leads. The test leads should be in good condition and properly connected to the meter. Damaged or loose test leads can affect the accuracy of the readings. Consider the impedance of the multimeter. Multimeters have an internal impedance, which can affect the voltage readings, especially in high impedance circuits. A high impedance multimeter is recommended for accurate voltage measurements. Be aware of ghost voltages. Ghost voltages are small voltage readings that can appear on disconnected wires. These voltages are caused by capacitive coupling and are not a sign of a real electrical problem. Ensure that the circuit is de-energized before taking any voltage measurements. This will help to eliminate ghost voltages. Use a non-contact voltage tester. A non-contact voltage tester can be used to detect the presence of voltage without making direct contact with the wires. This is a useful tool for quickly checking for energized circuits. Double-check all readings. Always double-check voltage readings to ensure accuracy. If possible, have another person verify the readings. When inspecting the wiring connections, it is essential to follow proper safety procedures. Firstly, always turn off the circuit breaker supplying the circuit before working on any wiring. This will help to prevent electrical shock. Secondly, use insulated tools. Insulated tools are designed to protect against electrical shock. Always use insulated tools when working on electrical wiring. Thirdly, wear safety glasses. Safety glasses will protect your eyes from debris and other hazards. Fourthly, avoid working in wet conditions. Water is a conductor of electricity, so it is important to avoid working in wet conditions. Fifthly, if you are not comfortable working on electrical wiring, contact a qualified electrician. Electricity can be dangerous, and it is always best to err on the side of caution. Regarding the garage door openers being damaged, consider surge protection. Power surges can damage electronic equipment, including garage door openers. Install surge protectors at the receptacles to protect the garage door openers from power surges. Also, consider upgrading the wiring. If the wiring is old or undersized, it may be necessary to upgrade it to handle the electrical load. A qualified electrician can assess the wiring and recommend the appropriate upgrades. Also, evaluate the location of the receptacles. The receptacle should be located in a safe and convenient location. They should not be located in areas where they are likely to get wet or damaged.